Okay, so in this video we're going to look at earthquakes very quickly. So what is an earthquake? Well, we all know what an earthquake is. We're familiar with watching it in movies and stuff like that. So an earthquake is sudden movement in the ground. It literally might last for 1 minute, but it can have dreadful impacts depending on where it happens, the time of day it happens, and the poverty or the wealth of an area. You know, are the buildings built of very good material? Can they withstand the shaking of the earthquake? Or are they very poorly built and will they collapse, as you can see in the photo? So an earthquake is the sudden shaking in the Earth's crust. It's sudden movement in the Earth's crust. Okay, it comes on, you really don't get any prior warning of it, to be honest. So most earthquakes will occur at plate boundaries where one plate meets another plate. And what happens is the convection currents of magma are underneath the two plates, and it's either causing the two plates to collide and press against each other. Pressure builds up and they're forced and squeezed against each other, and one plate slips. The minute that plate slips and moves, it shakes the earth. The other scenario that can happen is the magma is moving up underneath the two plates, causing them to slide past each other. But as they're sliding past each other at different speeds, they get jammed and stuck together. And then the pressure builds up and one plate slips and moves. Again, the minute that plate moves or slips, it shakes the earth, okay, for a few seconds or for a minute. And that's what we call an earthquake. So it's sudden shaking or movement in the earth. When an earthquake does happen, that sudden shaking that we feel on the land, on the ground, that shaking, we call them shock waves or tremors, okay? So shock waves or tremors is the shaking that happens during an earthquake. So like I said, earthquakes occur at plate boundaries where two plates will slide past each other or where they will collide, okay? The minute that plate slips past the other plate or it slips down past it, that fractures the Earth's crust. So you have a big fracture or a crack running along the Earth's crust, running along the land basically. And that big crack running along the crust of the land is called a fault line. So a fault line, it's where the Earth's surface is cracked, okay? So we have an example of it here on the left hand side of the picture. That's the San Andreas Fault. That's a big crack or fracture running all along the California, okay, on the west coast of North America. And that massive fault line or that massive fracture is caused by the North American plate and the Pacific plate moving in the same direction but at different speeds, and one of the plates slips and it fractures the land right running through San Francisco and Los Angeles there, okay? So there you can see the San Andreas Fault line. It's just a massive fracture running along the coast of North America. We'll get back to that shortly. So we know that the shaking during an earthquake, that shaking, that sudden movement, are called shock waves or tremors. When one plate slips, that point where that plate slips and that pressure that had built up between the two plates as they were squeezed and pressed against each other, when that pressure is released, when that plate slips, that pressure is released down in the Earth's crust. That point where the pressure is released, as you can see in the diagram, is called the focus. The focus is where the earthquake begins. Now the focus, which is the start of any earthquake, can be deep down in the Earth's crust or it can be quite shallow. Obviously, if the focus or the start of the earthquake where the pressure is released, if that's shallow, the movement and the shaking of the release of the pressure will get to us quicker. That's dangerous. That can do more damage. The deeper down the focus, the longer it takes the shaking or the pressure to come up to us. Okay, that release of pressure and that shaking, if it's very deep down, it takes longer to reach us and therefore it won't have as big of an impact. So the focus of an earthquake is where the earthquake starts, where it begins. It's where the pressure is released, where one of the plates slips past the other one. Okay, so that's the focus. That shaking or the shock waves, that pressure shakes out, releases out, spreads out from the focus, and it moves upwards, okay, up towards the Earth's surface. Okay, so it can happen anywhere in the Earth's crust, deep down or quite shallow in the Earth's crust. But that release of pressure, that shaking, okay, it comes up towards the Earth's surface, up to us, unfortunately. So the point directly above the focus, where the earthquake starts, up directly above the focus on the Earth's surface, is called the epicentre. So the shock waves come straight up, directly up from the focus, straight up to the Earth's surface above, to the point that we call the epicenter. So if your location happens to be the epicenter, you're going to get the worst of the shaking, the worst of the shock waves. The further out you're located, the less impact it will have, the less shaking you will feel. Okay? So an earthquake on average lasts about 1 minute. Now, it probably feels like far longer when you're living through it. I can only imagine how horrific it is, but really they don't last that long. Okay, anything else important there? So when the pressure is released, that's where the earthquake starts. That's called the focus. The point directly above the focus on the Earth's surface is called the epicenter. That's where the shock waves move directly up to, and they get the worst of the shock waves. Aftershocks are smaller shock waves that are released in the days following the earthquake. So it's probably when the plate is settling back down into place after moving, after slipping. So it's that movement of the plate settling back in and the last bit of pressure being released. So aftershocks are smaller shock waves that are released in the days following the earthquake. Now, they're not as strong as the main shock waves that happen in the main earthquake, but they can cause a building to collapse. If the main earthquake shook the building and made it unsteady or unstable but left it still standing, the aftershocks might be just enough to cause it to collapse. Okay, so they can be quite as dangerous. So I mentioned earlier about the San Andreas Fault line, which is a massive fracture running along along California. You can see San Francisco there, you can see Los Angeles, and basically it's caused by the Pacific plate moving past the North American plate. Pacific plate is trying to move faster past the North American plate. They're going at different speeds, they're jamming and sticking together, and one of the plates is slipping and fracturing the land just along the east or the west coast of North America. Okay, so there's the massive fault line or fracture called the San Andreas Fault. Now, what's a tsunami? A tsunami is not an earthquake. A tsunami is a massive tidal wave caused by an earthquake in the ocean. Okay, so if you get a release of shock waves in the ocean floor, underneath, in the crust in the ocean floor, if you get an earthquake in the crust in the ocean floor, the shock waves radiate up to the water and generate a gigantic tidal wave. That huge tidal wave is called a tsunami. That tsunami will just move towards the shore, move into the coastal areas, and can cause desperate destruction. Tsunamis can be very, very high. The waves can be very high, up to 10 stories high. As they reach the coast, they do slow down and they do kind of break as they reach the coastline, but they're coming in fast. Okay, and if the coastline is low lying, then it will just come straight in and sweep everything with it and cause desperate destruction. Okay, so it can wipe out entire coastal areas. So tsunamis can be very dangerous. What is a seismologist, or who are they? They're a person that studies earthquakes. They're like the volcanologists that we mentioned earlier. So they study earthquakes. So they try to predict when they will happen, why they will happen, how long they might last, etc. So they have special equipment to measure earthquake activity. So they try to predict when and where an earthquake might occur. So they try to look at patterns. Did they happen every 2 years? Did they happen in a particular zone? Okay. Very quickly, if we were to look at one case study, one example of an earthquake, Nepal would be an excellent example. So Nepal had an earthquake back in 2015, so a number of years ago. Look at the location of Nepal there on the map. So it's kind of lying in between India and China, such a tiny little country. So they got a very strong earthquake back in 2015, and basically it really devastated the region. So Nepal was suffering from the earthquake because it lies right between the Indian plate and the Eurasian plate. So naturally, it's going to get these earthquakes. The collision between the Indian and the Eurasian plate, basically the two of them were colliding, and this is happening now with millions of years, and it's not just dating back to 2015, but the Indian and the Eurasian plate are squeezing against each other, colliding with each other, and buckling up the rock. Okay, and that rock in Nepal is buckled upwards, and over millions of years, it's moved upwards into a mountain, a fold mountain, and that's what we call the Himalayas. So you're well familiar with them. Now back to 2015, when those two plates, the Indian plate and the Eurasian plate, were colliding again and squeezing against each other, and one of the plates slipped, it shook the land in Nepal. Okay, and it measured 7.9 on the Richter scale. So that's the strength of the earthquake. So the Richter scale tells you how strong an earthquake is on a scale of 1 to 10. 1 being you wouldn't even notice it, 10 being extremely high, causing devastation. So 7.9 on the Richter scale is quite strong. And when that earthquake happened in Nepal, it just lasted for less than 1 minute. In the days following the main earthquake, they had hundreds of aftershocks, measuring up to 6.7 on the Richter scale. That's quite strong. That would be unusually quite strong for aftershocks. So you can imagine that caused even more devastation. So like I mentioned, the Richter scale is a scale of 1 to 10. The higher up in the Richter scale you go, the stronger the earthquake was. All right. It's been replaced in recent years by the magnitude scale. That's the same thing base. Magnitude means strength. How strong was the earthquake? That's also a scale of 1 to 10. It's just more accurate. It uses more equipment. It's more accurate in the detail. So physically, how did that earthquake back in 2015 affect Nepal? Well, it actually fractured an area of land up to 120 kilometres of a fracture line. That's a serious amount of movement that happened. So you can see the fault line running straight through Nepal and India there. The epicentre, it was obviously the worst of it. It's very close to Mount Everest. Even in that picture there from Sky News, you can see the fracture all along the roadway there. So it's pretty dangerous right in the middle of the city. So when the land shook, when the earthquake was happening in Nepal, it obviously shook everywhere. Okay, so any loose rock would have moved as well. So it triggered hundreds of landslides. So like people were buried, villages were buried, land was destroyed. It buried roads and villages. So it's amazing the different things that can happen as a result of an earthquake. Avalanches occurred in the hill climbing regions and the mountains. And there would have been lots of people climbing in the Himalayas at the time as well. And they would have been buried in those avalanches. What else happened? Human impact of it. Sure, there was loads of deaths. And a lot of poor people, a lot of poor regions. So their buildings and homes are made of very poor, cheap materials anyway. So they haven't a hope of withstanding the earthquake. So you can imagine people lost their homes. The rescue efforts were probably unreal. 8,000 people died. That's a lot of people. One death is too much. 20,000 people were injured because of the avalanches, because of the landslides, the houses collapsing. 3 million people were made homeless because their homes were destroyed. So like, how many did we say were killed? 8,000 died, 20,000 injured, 3 million homeless. Loads of rescue efforts, and many more people not even found in the meantime, I'd say. On the economy, people lost jobs. The cleanup operation cost the government an absolute fortune, 8 billion euros. And that's a lot of money to a region like that don't have a lot of money anyway. Like, we'd manage it, but that's a lot of money to rebuild the region for them. It damaged cultural sites. So are you going to attract in tourists if that lovely temple isn't there anymore? Probably not. So it affected the tourism economy, which affects jobs. People are less inclined to want to go there to climb the mountains because they're a bit wary of an earthquake happening there. So that does affect the tourism industry. So how do we measure earthquakes? There is an instrument called a seismograph. Think a seismologist is a person that studies earthquakes and monitors them. The seismograph is an instrument that picks up if there's any movement in the Earth's crust. So it's hard to predict earthquakes, but these can pick it up maybe in the days beforehand. So what you do with this instrument is you anchor it to the ground outside, or it can be inside. You have to anchor it down so it doesn't move during the earthquake. It's not, tumbling around the place. So basically you have a weight and you have a pen attached to the weight with ink at the end of the pen. And as the Earth is moving and shaking, the movement of the pen with the ink is recorded on a rotating drum, which has paper on it. So as the ground is shaking and the seismograph is moving, the movement of the ground is recorded on the rotating drum of paper. So obviously the wider out the pen movements are, the stronger, I suppose, the shock waves are. The less movement of the pen, the least, I suppose, severe that the shock waves were from the earthquake. They can come in all different shapes and forms as seismographs. They can also be called a seismometer. So a seismograph or seismometer detects, is there any movement in the ground? If there is, it measures the shock waves and then it records them on the sheet of paper. Phone apps nowadays, for God's sake, you and I can download a phone app now on our phone and it'll pick up if there's any movement in the Earth's crust, unlikely where we are. But if you're ever on holidays, it might, give you peace of mind. So the Richter scale measures the strength or the force of an earthquake. So the higher up on the scale you go, the worse the earthquake was. Like I said, we've replaced this with the magnitude scale. So it's called the MMS scale. It's just more accurate. It uses seismographs and everything. It's just more accurate. The worst earthquake ever recorded was the earthquake in Chile in 1960. Now it measured 8.5 on the Richter scale. So the Richter scale basically looks at the devastation afterwards and takes people's stories into account. Whereas on the magnitude scale, they've upgraded it to 9.5. So that's the worst earthquake apparently that's ever happened. Will it be topped? Hopefully not, but it could happen. How do we predict and prepare for earthquakes? It's not easy, but there's a number of things that you can do. You can use laser beams. So you can have laser beams equipment anchored onto the ground outside. They literally monitor any movement in the ground. So if they detect any movement in the Earth's crust, that might detect that the Earth is shaking, and that'll pick up any movement. Seismographs, like I said, that detects if there's any movement coming up from the Earth's crust. I know you won't get much notice, but it's better than nothing. If you're living in an earthquake zone, you can, like we hold fire drills, you can have earthquake drills. Best thing to do is go under a table or under a door frame, protect your head. Anything else there? Put together an emergency kit. If you're in a house, if you're stuck, if you're buried under something, it's handy to have a flashlight, a bit of food in there, a first aid kit, a bottle of water, batteries, something like that. So it's a survival kit. Earthquake proof your home. So bookshelves, don't have them loose. Anchor the furniture to the wall. If you are a wealthy region and you know you're building in an earthquake region, when you're building, you're put in the foundation, put shock absorbers. Those shock absorbers in the picture, they're buried in the foundation of a building. And as the shock waves moves up to the crust, they absorb the shocks from the shock wave. So the building isn't taking the shock. Okay, so they're fantastic but fierce expensive. So you can literally put them into the foundation of your building. You can also put steel around the outside of your building. It's ugly looking, but the steel frame holds the building together. It's like a cage. You can build steel frame buildings, but again, very expensive, and poor regions that often get these earthquakes don't have the money to buy that. Okay, so that's everything to do with earthquakes. Hope that helps.